All right, so today we're looking at Chapter 8, Lesson 3, which is Functions and Equations. So here on our warm-up, it says the table shows the amount of money Carly earns based on the number of hours she babysits. We want to write a sentence that describes the relationship between the number of hours she babysits and her earnings. Very good. So, she earns $6 for every hour that she babysits. All right, now, does she earn the same amount each hour, and explain? So yes, her earnings increase by the same amount every hour that she babysits. We are going to write an equation to represent a function. Okay, so the next thing we're going to do is we're going to write an equation to represent a function. It says here you can use an equation to represent a function. The input, or the independent variable, represents the x value, and the output, or the dependent variable, represents the y value. An equation expresses the dependent variable in terms of the independent variable. Now yesterday, we've talked, actually not yesterday, just yesterday, but for several days, we've talked about all the different names of inputs and outputs. I want you to make sure you have these written in your spiral notebook, okay? So we are going to take a look at the input. Okay, the input is also called the dependent variable, which is also called the x value. Okay, so if you have that written down somewhere in your spiral notebook already, you don't have to write it down again. But if you don't have it written down, you should write it down. The output is also called the dependent variable, which is also called the y value. Now the difference between what we did yesterday and what we did today is yesterday we were writing the function rule. And the function rule was just in terms of the input. It was an expression, okay? Now, when we're working with our functions today, we are going to write them as equations. So, if they're an equation, it has an equal sign, right? And it says here, an equation expresses the dependent variable in terms of the independent variable. So that means that the output, y, is equal to the function rule that includes the x. Is everybody clear with that? Okay, and you'll see it in just a minute. All right, so this first example, you don't have to write it down. We're just going to talk about it. It says write an equation to represent the function shown in the table. So here's the table that they gave us. And when we do that, you're just going to look to see how do we get from one y value to the next. And the way we did that is each time we're adding 9. So because we're adding 9, that means we're going to take that 9 and we're going to multiply it times the input. Okay? So it's going to be a 9 times x. Is everybody with me? Okay? Now, when we have the 9 times x, when we substitute in and we get a value, we get the output value, correct? And the output value is which variable?
The y.
The y. It's the y, right? So when we write our equation, we just include the y equals. Is everybody with me? Okay? So the equation for this function table is y is equal to 9x. So the only difference between yesterday and today is we have a y equals. All right. So we want to write an equation to represent the function shown in the table. So you should write your table down. Okay, make sure you write your table so you have your information in your spiral. And then we're going to show our work on the table. Okay, so we're going to look at the pattern of our y values. So going from 16 to 32, how did we do that? We what? Add 16, right? Be careful, because if you, I heard someone say multiply times 2. If you can't multiply times 2 for every single one of them, then that's not the rule, okay? It has to be the same. So to get from 32 to 48, we add 16 again. And to get from 48 to 64, we add 16 again. And then from 64 to 80, we add 16 again. So each time we added 16, so that 16 is going to get multiplied times the input. And the input here is x, right? So we have 16 times x. Now we want to write an equation of the output in terms of the input. So here it is in terms of the input, right? So if I multiply 16 times any of the inputs, I'm going to get the output, which is what value? Which variable? The y. So all we do here is add y equals. So y equals 16x is the equation that represents the function table. Okay, so now we're going to graph linear functions. Now remember, if a graph is a line, if it's a straight line, the function is then called a linear equation or a linear function. Okay? When graphing the function, the input is the x-coordinate and the output is the y-coordinate. We've already talked about that. But I do want you to write down the definition of the linear equation. All right, so for this example, you don't have to write this down. We're just going to talk about this one. We're going to graph y is equal to 2x. So the first thing we do when we're graphing is make a table of ordered pairs. Okay, so we're going to make a function table. Okay, and in that function table, it just has an extra column that has the x and the y. And I'm okay if you guys leave out the fourth column because you see there's an x and there's a y already. Is everybody clear with that? Okay. So you can leave that out if you want to. All right. So when we make our function table, we're going to select any 3 values for x, and then we're going to substitute those values in to the function rule, and then simplify to get our y value. Okay? Now, let me point out to you, when you are graphing, okay, if you get to choose the numbers, I would suggest you keep the numbers small so that your graph will be able to fit on your paper. Okay? All right. So here, they chose 0, 1, and 2. Okay? So, once we choose those numbers, then we substitute into the function rule, and then we simplify to get our y value. So now you can see x comma y. What's my first ordered pair? 0, 0. So when you graph that, that's right there. The next ordered pair is 1, 2. So there's 1, 2 right there. And then our last ordered pair is 2, 4, which is right there. And when you draw your line, when you connect the dots, you see that it is a straight line. So this is a linear function. All right, so we're going to try some graphing ourselves. So we're going to graph the equation y is equal to x plus 1. Okay? So I'm going to go ahead and I'm just going to cross out these. I put too many in there. We're just going to do 0, 1, and 2. Okay? So the first thing we're going to do is we are going to make our function table. So the first column is for the input. The second column is for your function rule. And then your third column is for your output. The function rule is always the part opposite the y equals. Okay, so here our function rule is x plus 1. And now we just chose our numbers 0, 1, and 2, and we're going to substitute and simplify to get the output. So here, 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So, does everyone see the ordered pairs? X, comma, Y, X, comma, Y, X, comma, Y, right? So, what's my first ordered pair?
0, 1.
0, comma, 1. So here's 0, comma, 1, right there. The second ordered pair is 1, comma, 2. You see it? And the last one is 2, comma, 3. And then, of course, when we connect our points, when we connect our plotted points, what do we get? This is a linear equation. It is a straight line. All right, so example C, we're going to graph y is equal to 3x plus 2. Okay, and once again, I'm going to take out 3 and 4. Actually, 2 is probably going to knock us way off our graph also. All right, so we're choosing 0, 1, and 2, and then we substitute into our function rule. So 3 times 0 plus 2, so that's 0 plus 2 is 2. And then we have 3 times 1, which is 3, plus 2 is 5. And then we have 3 times 2, which is 6, plus 2 is 8. Good. And now we can graph our ordered pairs. What's our first ordered pair?
0, 2.
0, comma 2. Good. And what's our next ordered pair? 1, comma 5. Good. And our last ordered pair?
2, 8.
2, comma 8. So here's 2, there's 5, and I'm just going to go off the graph. So that's 6, 7, 8. About right there. And, once again, when we connect our plotted points, what do we get? Straight line, linear equation, linear function. Here, the graph shows the total amount, y, that you spend if you buy 1 book and X magazines. Make a function table for the input-output values. We also want to write an equation from the graph that could be used to find the total amount, y, if you buy 1 book and X magazines. So, the first thing we want to do is we want to create our table. Okay? And to get the information for our table, we have to look at our graph. Okay? Does everybody see which one is the X and which one is the Y in the graph? Okay? Down here, let's see. Down here, those are the X values, and the total amount is the Y value. Very good. So, if I'm looking at this first point right here, that's 1, comma 20, right? So which one is the X and which one is the Y? 1 and 20, right? So if I look at the next point right here, what's my ordered pair for that one? 2, comma 25. Very good. 2 comma 25. And then for the third one, what's that?
3,
3 comma 30. And then the last one is?
4, 35.
Very good. 4 comma 35. So we made our table, and now we want to write an equation from that information. So in order to do that, we need to look at the pattern in the graph. Okay? So to go from 20 to 25, 25 to 30, bless you, 30 to 35, what am I doing?
Adding 5.
You're going to add 5 each time. Very good. Now, what does that mean is going to happen with that 5? What do I have to do with that 5? So this 5 has to get multiplied times the input, right? That's how it always has been, yesterday's and today's. When we look at that pattern, if it's a plus 5, plus 5, plus 5, that 5 gets multiplied by the input, okay? If you look at the, where is it? Right here, our first example, plus 9, plus 9, plus 9. Does everybody see it? It gets multiplied times the x, times the input. Is everybody with me? All right, good. We're on the same page then. Oops. All right, so if I multiply 5 times the inputs, let's see if we get our output. Okay, so 5 times 1 gives me 5. I need 20. So what am I going to do with this 5 times x? How do I make 5 to 20? Okay, so to get to 20, we have to add 15 to the rule. Now we can check to see if we'll get that for all of the others. Okay, so 5 times 2 is what? 10. Plus 15 is? 25. Check. Let's see, how about 5 times 3? We do 5 times 3, that's what? 15. Plus 15 gives me what? Check. And then finally, we've got 5 times 4, which is what? 20. Plus 15, which is 35. Is everybody clear how we check that? Is everybody clear why we added that plus 15?
Yes.
All right. Very good. And we're done.